Welcome to your deep dive into AI and cybersecurity. You've given us quite the reading list this time.
Yeah.
Book excerpts, research papers, practical guides.
Wow.
We are ready to help you cut through the noise and extract the real gems.
Consider us your AI cybersecurity think tank,
I like that.
helping you connect the dots and understand what really matters.
Yes. We're going to unpack why AI and cybersecurity is such a game changer, and more importantly, how you can apply this knowledge to your own work and security practices.
It's a fascinating landscape, and it's evolving so rapidly.
Okay, let's dive in. One of the things that immediately jumped out from the book Artificial Intelligence for Cybersecurity was that the authors actually used AI tools like ChatGPT and Grammarly during the writing process.
Oh, that's a perfect example of how AI is already deeply integrated into our lives, often in ways we don't even realize, and it really underscores that AI isn't some distant future tech. It's here, it's now, and it's already having a tangible impact.
Yeah, absolutely. The book talks about how AI is being used to analyze those massive data sets that are so common in cybersecurity, things like network logs, threat intelligence feeds.
All that good stuff.
I mean, it's like trying to drink from a fire hose of information.
It really is, and that's where AI comes in. By using machine learning algorithms, security teams can sift through those mountains of data and identify patterns that would be impossible for humans to spot on their own. It's like having an AI-powered detective working around the clock.
Yeah, and one of the papers you shared goes deep into zero-day exploit detection, and it seems like they're leaning heavily on unsupervised learning techniques. And since zero-day exploits are by definition brand new and unknown, there's no labeled data to work with. So why would this type of learning be the preferred approach in that scenario?
That's a great question. In cases like zero-day exploit detection, where we're dealing with the unknown, unsupervised learning, really shines because it allows us to find anomalies, those deviations from the norm, without needing pre-existing knowledge or labeled examples. It's like trying to find a needle in a haystack without knowing what the needle looks like.
Okay, that makes a lot of sense. Now let's shift gears a bit and talk about SIEM platforms. You've included some documentation on IBM QRadar and Splunk Enterprise Security, which are popular examples of these AI-driven security systems. And the documentation mentions that integrating these platforms into existing security infrastructure can be a major headache. Is that a common pain point for organizations trying to adopt AI-driven security solutions?
It's definitely a challenge that many organizations face. Integrating SIEM platforms can be complex and resource intensive. It often requires specialized expertise and a deep understanding of the organization's existing security architecture. But the benefits can be significant, so it's often a worthwhile investment.
Okay, so the payoff can be big, but it's not a plug-and-play solution. I'm curious, though, what are some of the most compelling use cases for AI and cybersecurity that we're seeing right now? I mean, where is this technology really making a difference?
There are so many exciting applications emerging at boarding. Malware detection is a big one. AI is being used to analyze executable files and identify malicious code based on its characteristics.
It's like teaching a computer to recognize the fingerprints of a virus.
Yeah, exactly.
Speaking of malware, the book talks about transforming executable files into 2D images for analysis that sounds straight out of science fiction.
It's pretty cool.
I am curious, though, about the limitations of this image-based approach. Are there certain types of malware that it might miss, or are we talking about a silver bullet here?
While it's a powerful technique, it's not a silver bullet. The effectiveness of image-based malware analysis depends on several factors, including the quality of the image transformation process and the sophistication of the AI models used.
So it's a valuable tool in the arsenal, but not a foolproof solution. Got it. What about network intrusion detection? How is AI being used to protect entire networks from attack?
AI is playing an increasingly important role in network intrusion detection. Algorithms can be trained to analyze network traffic and identify patterns that indicate malicious activity. It's like having an AI-powered watchdog that can spot intruders trying to sneak into your network.
And one of the research papers you've included dives into the use of visual network traffic analysis. They're using tools like Wireshark to capture network traffic and convert it into images for analysis. It seems like we're seeing a theme here, turning data into something visual that AI can process. What are the advantages of this approach for intrusion detection?
Visualizing network traffic can be incredibly insightful. It allows security analysts to literally see patterns and anomalies that might be difficult to detect through traditional methods. And when you combine this visualization with AI-powered image recognition, you have a powerful system for identifying and responding to threats in real time.
That's fascinating. So we're not just relying on AI to crunch numbers anymore. We're giving it a way to see the problem.
Exactly. And that's leading to some really innovative solutions in the cybersecurity space.
Okay, let's talk about user behavior. The book has a chapter on user and entity behavior analytics, or UEBA. It seems like AI is being used to build these profiles of normal user behavior and then flag anything that deviates from the norm. Is that a fair assessment?
That's exactly what UEB is all about. It's like having an AI-powered detective that's constantly watching for suspicious activity by analyzing patterns of user and device activity. AI can help organizations detect insider threats, compromised accounts, and other security risks that might go unnoticed using traditional security tools.
That makes a lot of sense, but I imagine there are challenges in terms of fine-tuning these systems. You wouldn't want to be bombarded with alerts for every minor deviation from the norm, right? How do you strike that balance between security and not overwhelming security teams with too many false positives?
That's a crucial consideration. False positives can be a major issue with UEV systems. If you're constantly getting alerts for benign activity, it's easy to become desensitized and miss the real threats. Fine-tuning these systems requires a deep understanding of the organization's normal behavior patterns and the ability to adjust the sensitivity of the AI models accordingly. It's an ongoing process.
So it's not a set and forget it solution. It requires ongoing monitoring and adjustment.
Absolutely, and that's where human expertise comes in. AI is a powerful tool, but it's not a replacement for skilled security professionals.
This is all incredibly insightful. We've covered a lot of ground, from zero-day exploit detection and SIM platforms to malware analysis and user behavior analytics. It's clear that AI is already having a profound impact on how we approach cybersecurity. But what about the future? Where are things headed?
That's where it gets really exciting. One of the most promising areas of development is the use of large language models, or LLMs, in cybersecurity.
Okay, LLMs, those are the big AI models that can generate human quality text, right? What's the connection to cybersecurity? I'm intrigued.
LLMs are incredibly versatile, and they're already being used in various cybersecurity applications. For instance, they can analyze code to identify potential vulnerabilities, which is incredibly valuable for preventing exploits.
So LLMs can help us find and fix security holes before the bad guys even know they exist. That's impressive.
It's one of the many ways LLMs are changing the game, and because they're so good at understanding and generating human language, they can also be used for tasks like analyzing threat intelligence reports, automating security tasks, and even detecting phishing emails with remarkable accuracy.
It sounds like LLMs are going to be a game changer in cybersecurity.
They certainly have the potential to be, but like any powerful technology, it's crucial to use them responsibly and thoughtfully. And that brings us to an interesting point raised in one of the research papers you shared.
Oh, which one?
It's the one focusing on the use of AI in detecting and preventing fraud.
Right, right. I remember that one. It goes into how AI can analyze those huge data sets of financial transactions and identify patterns that might indicate fraudulent activity, like those too good to be true offers that are always a scam.
Exactly.
Yeah.
AI is becoming incredibly effective at recognizing those subtle red flags that humans might miss. It's like having a super-powered fraud analyst working behind the scenes.
Yeah, I'm really curious about the techniques they're using in that paper. What stood out to you?
Well, they delve into something called collaborative anomaly detection systems. Essentially, it's like a network of organizations working together to share data and improve the overall accuracy of fraud detection.
So it's like a neighborhood watch, but for cyber criminals.
Haha, that's a great way to put it. By pooling their data and insights, these organizations can create a more comprehensive picture of fraudulent activity and develop more effective countermeasures.
But I imagine data privacy is a major concern, especially when we're talking about financial information. How do they address that in the paper?
They discuss the use of federated learning, which is a really innovative approach. It allows multiple parties to train a shared AI model without actually exchanging their raw data.
So they're collaborating without revealing their secret.
Precisely. It's a win-win situation. They get the benefits of shared learning without compromising the privacy and security of their sensitive data.
That's fascinating. It seems like we're seeing this trend of collaboration and data sharing across different areas of cybersecurity.
It's definitely becoming more prevalent, and it makes sense the more we can share information and work together, the better equipped we'll be to combat these ever-evolving threats.
Speaking of evolving threats, one of the things that struck me in the book, Artificial Intelligence for Cybersecurity, was the emphasis on responsible AI. I mean, it's great that we have these powerful tools at our disposal, but we need to use them ethically, right?
Absolutely. The book dedicates an entire chapter to the ethical considerations surrounding the use of AI in cybersecurity, and it's a conversation we need to be having.
Yeah, for sure. What are some of the key takeaways from that chapter? What should we be thinking about as we integrate AI into our security practices?
One of the most important things is to ensure that AI systems are fair and unbiased. We need to be careful not to perpetuate existing biases in the data we use to train these models.
So if we train an AI model on data that reflects historical biases, those biases could be amplified in the model's predictions.
Exactly. And that could have serious consequences, especially in a field like cybersecurity, where decisions can have a significant impact on people's lives and livelihoods.
That's a sobering thought. What else should we be considering?
Transparency is crucial. We need to be able to understand how AI systems are making decisions, especially when those decisions have significant consequences. It's not enough to just trust the black box.
So it's not just about building powerful AI models, it's about building trust and accountability into the systems we create.
That's a great way to put it. Responsible AI is about more than just technology, it's about values ethics and ensuring that these powerful tools are used for good.
This deep dive has been incredibly insightful. We've explored the use of AI in everything from fraud detection to network intrusion prevention, and we've touched on the crucial importance of responsible AI and ethical considerations.
It's been a fascinating journey through the world of AI and cybersecurity, and it's just the beginning.
I'm curious, what are some of the emerging trends and developments that you're most excited about? What's on the horizon for AI in cybersecurity?
Well, as we discussed earlier, large language models are showing incredible promise. Their ability to understand and generate human language is opening up a whole new world of possibilities in cybersecurity.
What are some specific examples of how LLMs might be used in the future?
Imagine an LLM that can automatically analyze and summarize complex threat intelligence reports, freeing up security analysts to focus on more strategic tasks, or an LLM that can generate realistic phishing simulations to train employees on how to spot these attacks.
Those are great examples. It sounds like LLM could really help us automate a lot of the tedious and time-consuming tasks that security professionals currently have to deal with.
Exactly. And that could free up valuable time and resources to focus on the more complex and challenging aspects of cybersecurity.
What about other areas of development? What else is on the horizon?
I think we're going to see continued advancements in areas like anomaly detection and user behavior analytics. AI models are becoming more sophisticated and better at identifying subtle deviations from the norm, which is crucial for detecting insider threats and other sophisticated attacks.
So AI is becoming more like a human security expert, able to recognize patterns and make judgments based on context.
That's a great analogy. AI is evolving to become more intuitive and adaptable, which is essential in the ever-changing landscape of cybersecurity.
This has been an incredible deep dive. We've covered so much ground, from the fundamentals of AI to its real-world applications and the ethical considerations we need to keep in mind. But before we wrap up, I have one last question.
I'm all ears.
If our listener could take away just one key insight from this entire conversation, what would you want it to be?
I think the most important thing to remember is that AI is not a silver bullet. It's a powerful tool, but it's only as effective as the people who use it. The human element will always be crucial in cybersecurity.
That's a great point. It's easy to get caught up in all the hype, but we need to remember that technology is only part of the solution.
It is. Yeah.
Yeah.
Human expertise, critical thinking, and good old-fashioned security practices are still essential.
The book actually dives into some statistical concepts that I think are relevant here, things like correlation and causation.
Oh, yeah.
I found that section really interesting. It's easy to assume that just because two things are correlated, one must cause the other.
Right.
But that's not always the case.
Yeah, that's a really common misconception. The book uses a great example. Ice cream sales and crime rates tend to both go up in the summer, but that doesn't mean eating ice cream causes crime.
Exactly. There's probably a third factor at play, like hot weather, that's influencing both. So how do we apply this kind of thinking to cybersecurity and AI?
Well, it's important to be critical of the data we're using to train AI models. Just because we see a correlation between certain network activity and security incidents, it doesn't necessarily mean one is causing the other. There could be other factors at play that we need to consider.
So we need to be careful about jumping to conclusions and make sure we're really understanding the underlying relationships in the data. The book also talks about bias and variance in machine learning models. Can you explain why those concepts are important?
Yeah, bias and variance are two sources of error that we need to be aware of when building AI models. Bias refers to errors that arise from overly simplistic assumptions made by the model. A high bias model might oversimplify the relationship between variables, leading to inaccurate predictions.
So it's like trying to fit a square peg into a round hole. The model is too rigid to accurately capture the complexity of the data.
Exactly. And then there's variance, which refers to errors that arise from the model being overly sensitive to fluctuations in the training data. A high variance model might overfit to the training data, performing well on that data, but poorly on new unseen data.
So it's like the model has memorized the answers to the test, but doesn't really understand the underlying concepts.
That's a great way to put it. And in cybersecurity, we need to find the right balance between bias and variance to build models that are both accurate and generalizable.
Yeah.
We want models that can accurately detect threats, but aren't so specific to the training data that they miss new emerging threats.
This deep dive has been fantastic. We've covered so much ground from the fundamentals of AI and its applications in cybersecurity to the importance of responsible AI data quality and even those core statistical concepts. I feel like I have a much deeper understanding now.
Well, I'm glad to hear that. It's been a pleasure exploring these topics with you.
And I'm sure our listeners feeling a lot more informed and ready to apply this knowledge to their own work.
I hope so. The world of AI and cybersecurity is constantly evolving, and it's an exciting time to be involved in this field.
Absolutely. And remember, it's not just about the technology, it's about what you can do with it. How can you apply these concepts to your own work, your own security practices? That's the real deep dive.
Well said. The future of cybersecurity is being written right now, and AI is at the heart of it.
And with that, we'll wrap up this deep dive. We've provided some additional resources in the show notes, so be sure to check those out to continue your exploration of AI and cybersecurity. Until next time, stay curious.